can always find your objects because most of them are found in that plane across the sky, the ecliptic. They're not too far away from the ecliptic. So it's relatively easy to find your objects. They're not that dim for the most part, so you can usually find them. And they do have enough light that you can locate them, and it looks like it's an easy object to find. But that's only part of what it takes to view planets. Planets, from a visual point of view, suffer many problems. And the first problem, of course, is the small size of them. For instance, see how much easier the dark sky objects are and for viewing and imaging versus what it takes to look at a planet. These things are very small compared to the very large objects such as some of these nebulae. Here is a chart showing the variation in size of some of these objects. And as you can see, something like Mars has an incredible range of size from only 3.5 arc seconds all the way up to 25 arc seconds, as we saw back in 2003. Venus also shows an extreme range in size, but so does Jupiter and Saturn and all the rest of the objects. They all have some range in size depending on where they're located in the solar system. So you'll want to keep in mind how these objects are for size when you go looking for them. Usually the best way is to find them near opposition. That's when the Earth is between that planet and the sun. And here's a view of the solar system from outside, trying to show you that the objects that you're trying to find here, the planets, are mostly found all within a relatively narrow plane. And that's how it looks from a far view of the solar system. Here's how it cashes out for us as planetary viewers at this time of year. This top view is a view of the morning sky looking eastward, and I've blocked out the skylight so that you can see that the sun is here. This red line represents the celestial equator. That line is relatively fixed. It does move over 26,000 years, but that's of no consequence for us. So this line of the celestial equator is a good reference line. The green line that's coming down through here is the ecliptic. And this ecliptic is the line in which the planets are fairly close to. There may be a few degrees above or below, but most of them manage to stay quite close to the ecliptic. And you can see that the morning sky has the ecliptic quite vertical. Compare that to the evening sky at this time of year. So here's the celestial equator again, and the green line is the ecliptic, which is much flatter in the evening. So in the morning, if you're looking for objects that travel along the ecliptic, it could work out quite well for you because they will be relatively higher and in higher elevation above the sun. So when this sun was back down here and below the horizon, these planets were relatively far away and well above the horizon. The evening viewing of planets at this time of year is pretty tough because they'll stretch out low over the horizon here, even when the sun is above the horizon yet. So planetary viewing in the evening of the planets that are close to the sun are pretty tough to do. Planetary viewing in the morning at this time of year works out quite well for you. The objects are relatively high. Just the other day, I saw a 23-hour, 50-minute before new moon that was just nicely positioned with its horns pointing upwards in this part of the sky. And what made it so easy to see was the fact that this configuration of the ecliptic in the fall time, in the morning, works out well for having it well above the horizon and in much clear air. Now, this situation that you see right now of the morning being good and the evening being not so good is reversed in the springtime. In the springtime, the ecliptic will be above the celestial equator and running this way, and the morning sky will have it running in the opposite direction, and it'll be low. So springtime, evening observing close to the sun, fall time, morning observing close to the sun. So you'll want to keep in mind the time periods in which you're going to be doing your observing, especially of the planets that never get that far from the sun. Now, the one factor that's most important in the history of astronomy having to do with planets has to do with what we call retrograde motion. Now, this was known in ancient times, and this was incredibly important as far as the development of our understanding of the solar system and the rest of the universe. It's the sorting out of retrograde motion that eventually allowed us to adopt the Copernican system that talked about the Earth doing the moving rather than the sun. And it's also rather important for us as modern planetary viewers, because as you can see in this little model, the blue dot moving here is Earth, the red dot here moving is Mars. And when Earth is approaching Mars here, you'll notice that's when Mars goes into its retrograde motion. There's its prograde. This is prograde motion. Then it slow stops, retrograde motion, and then back forward again. And of course, this isn't a real motion of Mars. This is just how Mars appears to move as Earth passes it on the inside track. We're moving quicker, and it appears as if Mars moves backwards in our sky. And again, notice this is when we are also closest to Mars. So Mars looks largest. So keeping in mind when planets are going retrograde can help you know when you're going to be observing it at some of the most opportune times. But an awful large issue that has to do with planetary observing has to do with what we call the seeing conditions. And a lot of beginners may get this confused with the issue of transparency. These are two aspects of our skies when we go out each night to look at things. The clarity of the sky, how dark it is, how easily the stars stand out, that is the issue of transparency. The seeing conditions are how steady are the skies? How well behaved are those images? A lot of people think those dark wintry nights with the stars sparkling overhead must be great for astronomy. Well, yeah, they could be great for things like photographing DSOs and such, but they may not be the best of skies for viewing planets. Because with planetary viewing, we were looking at very small targets, and that means we want to use more magnification than we would for other objects. So even though planets are easy and bright to find and shouldn't be too much of a problem identifying in our telescopes, the fact that they have to be magnified this much makes this form of observing quite demanding. And this scale here is a reproduction of Environment Canada's abbreviated version of the Pickering scale of seeing. And this shows a very turbulent sky with the image of a star, a focused star, looking quite crappy. And you can progress up through the scale. And this translates into the seeing scale that you have here in the clear sky charts. So you can go to your local clear sky chart. This is the one for me. And take a look at the skies and recognize that, okay, on this night, Tuesday night, even though the cloud cover should be minimal, the transparency is relatively good, but there's going to be some really lousy seeing in the evening, and that you may not get very good views. And here's some simulated versions of Jupiter's image to try and convey just how big a difference the seeing conditions make. And probably the best, I mean, you can give all kinds of lectures. Matter of fact, I gave a presentation a long time ago on the issue of trying to beat the seeing conditions. But the most important thing to recognize in getting around the seeing conditions is once you know the forecast, you know the general conditions, your biggest asset is going to be patience. Just don't go take a quick look at things, spend some time at it and watch the objects for a longer period of time, because the great views that you might get of this variety could just be very fleeting. There's going to be very, very few nights when you're going to get class 5 seeing that's going to last an entire night. So your opportunities of seeing beautiful details on Jupiter, and detail of about this level is possible if you are patient enough to finally look through and see past the moments of bad seeing. One little piece of advice I can give about this is that seeing tends to be better in the morning. If you look at the comparison of this map, this is like 8 o'clock at night or something like that. Maybe even a little earlier. This is, let's see, 00 Zulu. So that's like 7 o'clock in the evening versus 4 in the morning. You'll see the darker patches indicating better seeing form towards the morning. There's some forming here, some forming up here, a big swath coming in from Washington State across Alberta. So your chances of better seeing are later on in the evening. So that's something you might want to keep in mind as well. The exception in this was, looks like I had much better seeing early in this evening than I did later in the evening, but that's my kind of luck. Now, the objects we're going to be looking at. Mercury is the innermost planet, and in some ways, we've been neglecting Mercury. It's a planet that hasn't had an awful lot of space exploration. It's difficult to observe because it never gets that far from the sun. It's the innermost planet that orbits the sun, and it swings around from the westward side of the sun, around to the eastward side of the sun, and back again in a very short period of time, just a matter of some tens of days. Its orbital period is what, 80 some days. But the interesting thing about Mercury is, even for basic beginner's observations, you should be able to make out the phases of the planet, and that's indicated in this chart. This is a very difficult observation to make, of course, because you've got the sun in line with it. This is a very tricky thing to do, and you should exercise such caution if you ever want to see it in that fashion. But this Western elongation, which means this crescent version of Mercury would be getting up just before the sun would, should be able to be seen in that way. Again, as it moves further from the sun, it takes on different shapes, goes around. A full planetary image would be, again, very difficult to obtain. So these are usually the kinds of phases of Mercury that would be easily or more easily done with a telescope. Now, just how much detail can you see? Well, here's some imaging that has been done. I mean, this is done with the Mount Wilson telescope, but it was done by amateurs who were essentially, renting the telescope for the evening and being able to go off and do their usual imaging work. And they ended up with these kind of images, which compare quite favorably with the Messenger spacecraft that flew by. And here's some other, this of course was done with the large Mount Wilson telescope in some of the most steadiest skies on the planet out over the Los Angeles Valley there. But here is some images that were done with 10 inch telescopes to show you that amateurs can do that kind of a thing. Venus is another inferior planet, one that orbits inside the sun. And so it has this kind of surface, but it's usually shrouded in its clouds. You will usually only see this for detail at that point. And now you'll have, again, a ability to see the various phases of Venus. As it comes around the back of the sun, the image grows larger and ends up eventually passing in front of the sun and becoming tricky to look at. So you'll have that to work with. Inner planets like Mercury and Venus, can also transit the sun. And here's some examples of what it has looked like in the past. Unfortunately, this is the year 2021. The next pass, unless you're planning on living over 100 years, you won't see another Venus pass. The passes of Mercury, I think the next one is like 2032 or something like that in June or something of 2032. So we've got a long ways to wait for any more transits to be viewed. Mars is always a wonderful target, but it also disappoints most of the time because it can be very small. Here is the next big approach of Mars in December of 2022, when you can do observations. Here's some of Mike's wonderful pictures of Mars from the last opposition from last fall. Here's more along the lines of what you would see if you were a visual observer at this point. These kind of sketches kind of show the level of detail that are usual, possibly usual at that time of year. And this little chart shows you the relative sizes of Mars over that period of time. So December 1st of 2022 will be the largest image you'll get of Mars. So you've got some time to practice and get ready for that. And the nice thing is that opposition of Mars has it very nicely high in the sky in the constellation Taurus. So from September through to the next year in March, you have it doing its retrograde loop. So we'll have it nice and high in our skies for that period of time. Another object to see at this time of year, and Darren actually suggested this as a project to plot the locations of the asteroid Ceres as it moves. This is the Hyades here, and this star here is Aldebaran. And Ceres right now is doing its retrograde loop, which means it's relatively bright in our sky, 8th magnitude or something like that. And that's a fun object too for beginners to just plot. And if nothing else, get familiar with the Hyades. But the big showstopper these days is the planet Jupiter. A couple more of Mike's images of the big planet. And next to it, I think Mike took this picture a day or two before I did this sketch. So you can get an idea of how much detail I was able to see visually compared to what Mike was capturing with his cameras at this point. Mike also likes to take images in the near infrared to get as much detail as possible. But before he did any of that, he used to make these lovely stylized sketches of his observations of Jupiter, and hopefully he'll get back to doing some of that in the future as well. When you want to talk about Jupiter events, you want to learn some of the nomenclature, some of the labels talking about the different features on Jupiter so that you can make reference to it when you're communicating the features that you see on Jupiter. So learn a few of the things. They're not too difficult to figure out what they are. But there's whole lists of these if you want to get technical, but these are the major ones you'll want to learn. Temperate belt, the north equatorial belt. This lighter zone in the middle is the equatorial zone. The lighter ones are called zones, the darker ones belt. But when you're looking at Jupiter, the other feature to try and capture is some of the time-sensitive events. The moons of Jupiter regularly pass in front of the planet, and so does the shadows of each of these moons. And these are quite visible. They look like bullet holes on the planet, even in some really crummy seeing. So you'll want to start looking at the Observer's Handbook, which has a list of these, or use a desktop planetarium program. Sky and Telescope has a nice little program to help you figure out when these events are happening. And these are all visible to amateurs with their telescope. Saturn, one of the showstoppers of the solar system. You can have various orientation of Saturn's rings. I think we're something like about this right now. And over the next 4 years or so, the rings will tend to go disappear. And then over the next 7.5 years or so, they will widen back out again. I think this takes about 15 years to go from here to there and then back again. Here's a sketch that Mike did again of the planet back before he was doing all this imaging. Here's just one of his images. He's taken lots of other images, but this was just one I threw in there because it was most recent with lots of detail to it. One other thing to note for observers of Saturn is in addition to the planet itself, you might want to look for the moons. There's about 5 of them that are readily available to amateur telescopes. Titan is usually available almost all the time, and the other 4 require some good conditions and some luck in having them at a particular distance from the planet so they're not lost. But those are objects you can always go hunting for when you're looking at Saturn as well. Uranus is a much tougher planet, and there's not too much to see other than maybe this pale blue-green dot. This is in scale to Earth right now. Here's a picture showing the orientation of Uranus in our sky. It's a planet that's not quite well behaved. It's been knocked over on its side and orbits in a different fashion. So keep that in mind when you go looking for things like the moons around Uranus. And here's some examples of how well the pictures of Saturn are coming up. Here's the spot in the sky where you're going to find Uranus, which is found right down over here in the constellation of Aries. So that's where you'll find that. Neptune, further away, tougher to see, dimmer. Here's some of the better views that imagers have been able to capture. So you won't expect to see much more than a blue dot in the sky, but you might be able to see its largest moon as shown in this picture here. And here's where Neptune is found. This is the ring that's at the top of Pisces. This is the planet Neptune here. This is the edge of the constellation Aquarius. Now, a lot of people would like to know what sort of equipment to use to view planets. We can spend all night talking about that. There's plenty of things to say about that and endless discussions to be had. I only have, and I've used every kind of telescope, it seems, to look at planets and such. But 2 things I think that you should consider very seriously if you want to get into planetary viewing is get a tracking mount. And for visual use, it doesn't matter if it's an alt-azimuth mount, German equatorial mount, or even a Ponset mount for your Dobsonian telescope. You guys are handy enough to start constructing these things. Get a mount that tracks. It'll be so much more convenient to do any serious planetary observing if you have a mount that can track. The other accessory that I think might be worthwhile, especially for the brighter planets, is try binoviewers. Yeah, it's going to cost you more money to buy the binoviewer and then get eyepieces that are fancier and everything done that way. But even relatively cheap eyepieces, when your brain has the 2 data sets to use, you don't worry so much about how wide a field of view is. All of a sudden, even the narrow fields of view are comfortable, and you're able to get better views with even modest eyepieces that will rival the best views you will get through fancier monocle viewing. So if you get a chance, try out bino viewing and see if that doesn't work for you. A couple of events that are going to be kind of neat to see with viewing planets is this January, there's a lovely alignment of planets with Venus, Mercury, and Jupiter, Saturn, crescent moon on the 4th, actually the 3rd, it'll be down here. And even Neptune will be up in your sky here, and then Uranus would be even further up there. So this January 4th, there's that lovely alignment. There is a stunning conjunction of Jupiter and Venus, Mars, Saturn, Neptune, on the morning of April 30th. This coming year as well. That'll be something to look forward to, especially if you're lazy trying to track down objects. It'll be really easy to find some of these. And even later on in the month, you've got a very crowded sky with Venus, Jupiter, Mars, and Neptune all bunched together here so that you'll be able to, won't have to move too far to catch many planets in the morning sky. So that's all I really have to say about observing planets right now. If there's any quick questions, we can get through that. But
so if anybody's got questions, you can either ask them or put it in the chat. And I don't think we've got any tonight there, Gerry. So
okay.
Thank you very much, Gerry, for the presentation. Oh, sorry, Gerry, we do have one question. It appears to be, what makes for better seeing?
Air that behaves itself. But yeah, that's a big loaded question. The one thing that you want to look for maybe is go outside and see how badly the stars are twinkling. Now this can fool you sometimes because you can have conditions where a lot of stars low to the horizon look like they're twinkling. So try and find a star that's about the same altitude up and in the same direction as the planet you're looking at and see how badly it's twinkling. If it's relatively steady, you might have a good chance at getting some good seeing. There's so many other factors to deal with in all of that. So it would take another whole lecture to go through all the factors on that, but look for the twinkling. It's a sign that things may not be all that great.
Good evening, everyone, and welcome to the meeting. We've had a slight change for our agenda tonight. We're going to introduce our main speaker now. So I'm just going to introduce our Dr. Richard Schmude Jr. was born in Washington, D.C. and has lived in 5 different states in the United States. He received his PhD degree in physical chemistry in 1994. He has been employed as a professor at Gordon State College since September 1994. He currently resides in Barnesville, Georgia, and still carries out brightness measurements of the planets, including Jupiter. He is hoping to write a book about Mars in the near future, and he is currently the Jupiter coordinator of the Association of Lunar and Planetary Observers. He is a member of the Kingston Center of the RASC, so he's a fellow rascal, and is also a life member of the RASC. His grandmother was born in what is now Thunder Bay, Ontario, and he graduated from a Catholic high school in Kingston, Ontario. Please welcome Dr. Richard Schmude. You're muted, Richard.
Right now, I guess that I'm trying to get my talk up.
Do you want me to display from my end, or do you want to do from your end there?
Why don't you do it from your end? That would make it
okay.
easier. Yeah.
Sure. Okay, just give me a minute here.
Well, how many people have seen Jupiter in the last few months? Raise your hand. Okay, very good, very good, very good, very good. And it's actually very bright right now, provided you got clear skies. Tonight, what I want to do is I want to talk about some recent developments on Jupiter, really 2 of them just this year, and then one of them back in 2019, a very interesting development there. And I believe my paper has just been published in the Digital Journal of the Association of Lunar and Planetary Observers. So, and it covers the flaking events of the Great Red Spot. So in this next slide is an overview of the talk. First off, I want to make a few introductory remarks. Sort of pick up where Silva left off in his great talk. And then I want to talk about the Great Red Spot. This is a huge storm on Jupiter. And then I want to talk about something that just happened not even a month ago. Last month on the 13th, there was a big flash on Jupiter. And then I want to talk about the North Equatorial Belt. It's really been strange this year. And then just wrap up with some brief conclusions. Now, just as a general note, Jupiter, it's interesting because it's always changing. Something's always changing. Now, John Rogers over in the United Kingdom, he's watched Jupiter a long time, I believe 40 years, 40 plus years, and he's gotten used to some of the changes. He can almost make predictions. And my hat's off to him. He's really a Jupiter expert, and I'm just trying to do my best with what I have and the extensive records that I have. So in the next slide, let's just talk about some introductory remarks. Jupiter, of course, has a gaseous atmosphere. You cannot see a solid surface on Jupiter. Mercury, you see the surface, but you don't have an atmosphere. So it's the opposite of Mercury. Jupiter is dominated by jets. Now, basically, these are jet streams. You probably are familiar with jet streams here on the Earth, I believe, in the northern hemisphere. It runs, it sort of dips around, sort of probably the northern United States and maybe in southern Canada. It kind of varies a little bit. It's not straight like Jupiter. Jupiter's jet streams are a lot more straight and parallel to the equator. And that's probably partially because of Jupiter's very fast rotation, something like 45,000 kilometers an hour at the equator, compared to Earth's 1,700 kilometers per hour. So Jupiter's whipping around there about 25 times faster than the Earth. Okay, and that probably is why the jet streams are a lot more straight and parallel, whereas the Earth is kind of like that. And sometimes the Earth's jet stream can even get as far south as where I'm at. And then Jupiter has cloud belts. Now, a common misconception of the beginner, you know, if you do public outreach, people will say, well, I see the rings of Jupiter. Well, got to correct them. You can't really see the rings of Jupiter. Even the Hubble Space Telescope can't show them. So we have to tell these people who are just starting to look through the telescope that they are cloud belts and not rings. Okay, I've encountered that a lot. And the cloud belts are bordered by wind gradients. And if you look at John Rogers's book, classic book, The Giant Planet Jupiter, which I will show you, it's this book right here. He talks all about that. I mean, so very good book. He wrote it back in 1995, but it's still a classic, and it's a really good book. You probably will have to buy it used, though. I don't think it's in print anymore, but I've got 2 copies. I actually purchased one, I think, and I got one to review. So, all right, now on the next slide, let's take a look at a picture of Jupiter. I've got north at the top. I believe in all of my images, north will be at the top. And you can see a sort of brownish stripe. It's just above the center. That is the north equatorial belt. Then you can see sort of a golden honey-colored belt right in the center of Jupiter. That's sort of the equatorial zone. Okay. And then as you go further south, you can see a little dot. That's actually probably a shadow of a satellite. And Silva talked about that just a few minutes ago. I mean, Jupiter is really excellent because you can see shadows of satellites. You can see the satellites transit. And then Callisto is so dark, Callisto will actually appear as a shadow when it's transiting Jupiter. And I believe that this year, you can actually, if you time things right, see and watch Callisto transit Jupiter, and that doesn't happen too often. So you might want to take a look at that, and I believe that those are predicted in the handbook that the RASC puts out every year about this time of the year. All right. Anyway, the cloud belts on Jupiter are named, and in the next slide, I give you a little table. What you want to do is start with the very central area. That's called the equatorial zone. And then you've got a northern hemisphere and a southern hemisphere. And I've got north at the top, south at the bottom. So you start at the equatorial zone. The next big belt is the north equatorial belt. And to the south, it's the south equatorial belt. And then it alternates between belts and zones. The southern hemisphere has been a little strange, though. Sometimes the south-south temperate belt is not quite visible, but the northern hemisphere is a little bit more ordered. So there's that little bit of asymmetry, and I think part of it has to do with the Great Red Spot and perhaps the oval BA. All right, so now let's talk a little bit about images and some nomenclature with regard to images in the next slide. All right, we have a variety of filters we can use. Here on Earth, at the surface of the Earth, we can use filters that range from the near ultraviolet all the way out to the near infrared. Typical CCD cameras are sensitive to wavelengths between the near ultraviolet out to the near infrared. Now, if you have a little bit more money, you can buy cameras that are sensitive even further into the infrared. And there's actually one group in the United Kingdom that actually has a camera that can go out to roughly 2 microns, the wavelength. So again, I think there's some good work that's going to be done there. And of course, the James Webb Space Telescope is about to be launched, and that is mainly an infrared telescope. It's not a visible light telescope, so you might want to keep that in mind. Now, a lot of people like to also record methane band images. I believe, Mike, you have done that. And these are very interesting because the methane band image is sensitive just a very narrow range of infrared wavelengths. And the purpose is to detect very high altitude clouds. If something is bright in a methane band image, that means it is very high up in the atmosphere. You're not going to get low stuff in a methane band image. So bright features in methane band light are at high altitudes. All right, so let's go on ahead and talk now about the first feature. I want to talk about the Great Red Spot. So in the next slide, Jupiter's Great Red Spot has been observed at least since the 19th century. Unfortunately, not a lot of observing happened in the 18th century. And so I'm not really sure we can say it's been observed since the 17th century. People did observe something that resembled the Great Red Spot in the 17th century, but there's that big gap, like I said, in the 18th century. So I'm going to just say since the 19th century, I think around 1830. It's basically a giant hurricane-like storm on Jupiter. And what's interesting is that in the last 40 to 50 years, it has been shrinking. John Rogers talks about that. I've been able to verify that as well in some of my reports. I mean, what I'll do is I'll compare a picture from, say, 1930 to 1970 to 1990 to 2015, and just take a look and see. And what you see is a gradual shrinking. You don't see a big shrinkage. It's just like 0.5% a year. But you know, over 40 or 50 years, that adds up. Another change that has taken place in the Great Red Spot is that its rotation. Now, of course, the Great Red Spot is elliptical. Back in about 1980, it made one trip. I mean, the winds made one trip around the Great Red Spot in about 7 days. But in the last 10 years, things have speeded up. Now the winds are only going, it may only take them 3 to 4 days to make a trip around the Great Red Spot. Now, part of that's because the Great Red Spot's getting smaller, but the winds also seem to be intensifying. So stay tuned there. There's still good work to be done, you know, from the Earth-based observer. Okay. All right. Well, let's take a look now at the next slide. Now, the modern images, that's images in the last 10 years. It depends what color light you use. Now, if you use the red, green, and blue light and put it together and make a color filter image, you're going to see a dark bar in the middle of the Great Red Spot. It's just sort of a little grayish bar. Sometimes that changes shape. I talk about that in some of my reports. But what's really neat is if you look at the methane band images just this year, 2021, the Great Red Spot looks different than it did just a year ago. And basically there is a dark little circle in the Great Red Spot, then a very bright center. And I have not seen that before until just a few months ago. And some really good images have been made by several different people. I can mention Chris Go. I believe Clyde Foster in South Africa has done some good work. And perhaps, Mike, you may have even imaged it as well. I can't remember all the people who have, but I know that several people have imaged this. All right, well, let's take a look at a picture of the great red spot in the next slide. All right, that's the great red spot. The big white arrow shows it. This is a picture made by Gerry Walker, and it's in the red, green, blue filter sequence, which is basically close to what you would see with your eyes. Some interesting things. First off, north is the top, south is at the bottom. What's this sort of dark brownish stripe? What is that called? Anyone? That's the North Equatorial Belt. That's what's left of it. Now, just a couple of years ago, the North Equatorial Belt was probably 3 to 4 times that thickness. But this year, it has shrunk to just that much. This is the thinnest I have seen it, at least in 26 years. So this is just really an amazing change that's happened. And to give you an idea of how much it's shrunk by, these little dark areas are called barges. The barges above this little thin stripe were actually in the North Equatorial Belt. They typically are inside the North Equatorial Belt. And you can see they lie well above it now. So this is truly a phenomenal change that's happened here. But you can also, like I said, see the detail inside of the great red spot. That's the main thing. I'll come back and talk about the North Equatorial Belt a little later. Now, what I'm really excited about is this next slide. Here I've got the great red spot again, and this is what I was talking about. You have internal detail here. Very good image taken by Gerry Walker just really a few days ago. And note, you've got sort of an outer layer that's white. Then you got sort of this little dark ring. It's a little darker, probably lower altitude. And then right in the center, you've got a bright little ellipse. Now this is just amazing to me. I was just really excited. And this is a new development. I'm pretty sure it is a new development. I don't think it's due to improvements in technology, although it would be interesting to see, you know, if I'm proven right on that. So really good job. And it's not just Gerry Walker. Several others have imaged this. I'm pretty sure Chris Go has done this. I'm pretty sure Clyde Foster has imaged this as well. All right, now here's the next thing I'm going to do. I'm going to ask everyone to get a, if you've got a piece of paper and a pen, I'm going to want you to do this question here. We're going to see how well you understand material. We're going to do, normally in the past, I'd actually have you vote on this, but since we're online, I think it would be best if you just write down your answer and compare to what it gets. So in the next slide is your first question. Think about it. Give you about a minute. All right, give you a few more seconds. All right, you ready? Let me know if you're not. All right, well, is the great red spot growing? No, it's actually getting smaller. So A is wrong. Is it rotating faster? Yes. All right. And obviously, it's a feature that's been observed for well over 100 years, probably close to 200 years. So the correct answer is choice F as in Fred. Okay. So Let's move on now to the next one. I want to talk a little bit about something really interesting that happened back in 2019 and a little bit in 2020. And that is basically flaking events. A flaking event occurs when a portion of the great red spot actually breaks away. Okay, for example, you got the great red spot here, you got a little part of it breaks away. And you can even see the color. I mean, the great red spot has sort of a reddish color. You see a little bit of a portion, a little red portion actually start to break away. And this is very common, especially in May of 2019. For some reason, that month was really active. And what people observed was that when several of these flaking events occurred, the great red spot did become smaller, 5 or 10% smaller in area, I believe. And basically a typical flaking event happened when, first off, you had an oval in the south equatorial belt south jet stream, and it would come down and then it would merge into the great red spot, get sucked up, and then that would cause a flake to be released. So there seems to be a relationship between ovals merging into the great red spot causing the flaking event. And of course, John Rogers has been on top of this. I did publish, I believe my paper has just been published, the 2018-2019 Jupiter report, and that is in the Strolling Astronomer. If you're a member of the ALPO here in the United States, you would be getting that paper. In fact, you should have already gotten a digital version, and I believe you get hard copy later this month. So this flaking event is really, really something. Now let's take a look at a picture of the flaking event, both in methane band light and in visible light. So this is shown in the next slide. Next slide.
Sorry, just stopped working here for me.
Uh-oh, okay.
Hang on.
Okay.
I don't know what happened there. Oh, there we go.
There we go.
Okay. Is that the right one? Okay, good.
That's
Yeah,
right.
sorry about that. Okay.
Got it. All right, now let's look at the image on the right first. You can see the orange color of the great red spot, and you can see this sort of, I don't know what you'd call it, a flake or a blade or whatever. And it's just throwing this material up into the atmosphere beyond the great red spot. Okay. And then right here, you can see it again. You know, this is, remember, white is high altitude and the darker colors are lower altitude. So you can see this sort of flake coming off here as well. Okay. So this is an excellent picture, both taken by Clyde Foster down in South Africa. So some very good work here. And again, excellent seeing, undoubtedly. So Silva, you showed an image that looked really sharp, and I think this would rank it at near the top of your seeing scale here. So really some good detail. Now, if you look right here, just to the right of the center, you'll see a little oval. Okay, and that little oval is between the two dark bands here. That is in the south equatorial belt jet stream. That little oval will eventually merge with the great red spot, and it will trigger yet another flaking event. And again, this is, I discussed this in my 2018-2019 Jupiter report. So really some good stuff. And of course, if you go to the website of the British Astronomical Association, John Rogers does an even better job of describing these events, but you have to go to the website. I mean, he's got digital publications there. So some very, very good stuff. I believe Juno has imaged this, but I may be wrong on that. All right, now let's go ahead and do a couple of more questions here, voting questions. The next slide has got a question for you.
Okay, sorry. I don't know why it's not responding.
Okay.
Yeah, just see if I can get it to go a different way. There we go. Okay, sorry about that.
Okay, very good. Give you a few seconds to answer this one. Okay, give you just a few more seconds. All right, let's take a look at this. Methane band images do not show light that we can see. The methane band actually is beyond the visible range. It's around 0.9 micrometers. We can see light with wavelengths up to about 0.7 micrometers. So we cannot see that, but your digital camera can. Okay, so A is not correct, but B is correct. And methane band images show high altitude features as bright. In fact, if you recall the previous talk that Sylvia gave, the images of Uranus and Neptune showed bright features. And I'm almost sure they were taken either in near infrared light or possibly methane band light. I don't think amateurs can do well with methane band light on Uranus and Neptune, but they've been very successful just using the wideband near infrared filters. Okay, so anyway. Okay, let's take a look at another question in the next slide. Okay, give you a few seconds on this one. Okay, give you a few more seconds. All right. A flaking event is when part of the Great Red Spot breaks off. That is true. GRS, by the way, stands for Great Red Spot. And it also happens shortly after an oval in the SEB jet merges with the Great Red Spot. So both of those are correct. So the correct answer here would be C, choice C. All right, now I want to, in the next slide, I want to talk about a recent impact event here on the Earth. Back about 8.5 years ago, it's February of 2013, an object roughly 15 to 20 meters across slammed into the Earth. And it reached a peak brightness even greater than that of the sun. A scientific paper was done. I believe they analyzed dash cam photos of this event. And I believe they said it was like 10 times brighter than the sun at its peak brightness. The object was about 18 meters across with an explosive force of about 500,000 tons of TNT. So it was quite an explosion. Fortunately, it happened about 20 miles above the atmosphere. So again, nobody was killed, but a lot of people were injured. Now, had we been standing on Jupiter, this event would have reached about magnitude 4 or 5. Okay, depends a little bit on the distance between the Earth and Jupiter. So this would have been even visible from Jupiter, you know, had somebody in Jupiter had a telescope. So this is quite an event, and a lot of light was released for just a very fraction of a second. Now, in the last 12 years or so, we have imaged several flashes on Jupiter and then one sizable impact event. So in the next slide, I mentioned this. 7 impact flashes have been imaged on Jupiter, including the one just a month ago. And then an additional impact took place back in 2009. And Anthony Wesley, I believe, was the one who first drew attention to it. And this object back in 2009 probably had a diameter of something on the order of 500 meters. So it was sizable. Since then, we've observed several flashes on Jupiter that have lasted something like 1 or 2 seconds. And we're pretty sure they're not cosmic ray strikes. You know, that could cause that. And the objects I estimated, if I scale the Chelyabinsk event to the Jupiter events, something on the order of 5 to 15 meters across. So something about as big as a small house causes. And then we just had an event within the last month, September 13th, 2021. And this object was a little bigger, probably on the order of 20 to 30 meters across, although I want to look at that a little closer. There is, again, a little bit of uncertainty. First off, we don't know the composition. If it's iron, that would be one diameter. If it's a rock, there would be another diameter. Obviously, an iron object, you're probably going to get more bang for the size, so, because iron's a lot more dense than rock. All right, so let's take a look at one image showing this impact flash. And this is made by a man down in Brazil in the next slide. John Pereira, I think is how you pronounce his name. And of course, the big black arrow points to the flash. And it lasted something on the order of 1 to 2 seconds. So again, it was on several frames in the video. And quite an impressive flash, probably something on the order of magnitude 3. So a little brighter than the previous flashes. This is probably the brightest flash we have seen on Jupiter that I'm aware of anyway. And again, I need to look at the calculations a little bit more, but something on the order of 20 to 30 meters across created that. That's what I believe. Now, of course, it depends on the velocity, which, again, I don't know, and other variables like the composition of the object. All right, now, before I leave, I did want to mention just briefly the North Equatorial Belt and how narrow it is. So in the next picture or slide, I list just a little bit of that. Oh, okay. And of course, yeah, I just kind of summarize this right here. Before I go on to the next event, I analyzed images of where this flash occurred, and there's no impact scar greater than 1,000 kilometers. If there's an impact scar, I'm guessing if it's 20-meter objects, it's probably on the order of 200 kilometers across, about 10,000 times bigger than the object. That's sort of what I'm estimating. So again, Earth-based images wouldn't show it. Unfortunately, the Juno will not be able to image Jupiter at that time, that location. All right, so in the next slide, I want to talk briefly about the North Equatorial Belt. In 2021, it has become very, very narrow. It has not been this narrow in at least 27 years. It may have faded and gone out completely a century ago. It would be interesting to look at that. But I haven't done that really yet. I hope to do that once I get this Mars book taken care of. And of course, as I said previously, there are those dark little ovals that lie north of the North Equatorial Belt. In previous apparitions, they'd actually be in the North Equatorial Belt. So again, that's sort of a first. And just a good drawing done by Abel in the next slide. You can see again, north is at the top, a very good drawing here. And he's got a very thin, sort of brownish stripe just above the center of Jupiter. That is the thin North Equatorial Belt. And if you look at the far right, there's a little smudge above it. That's undoubtedly one of the barges. So I believe it's Paul Abel did a really good job, and he made the sketch just 2 or 3 weeks ago. So a very good job there. So finally, in conclusion, in the next slide, Jupiter is constantly changing, and that's why it's important to image and study it, especially when it gets close to the sun, because that's when nobody else is studying it, okay? So some recent changes on Jupiter, the Great Red Spot underwent several flaking events in 2019. I believe it went through a couple or a few in 2020. I'm not sure about this year because, like I said, I haven't looked at the data that carefully yet. We did have a big flash on September 13th. More than likely, it's an impact. However, I can't rule out other things, and I'm guessing there may even be a paper published on this. And then, of course, the very thin North Equatorial Belt. So those are three of the changes. There's undoubtedly others, but again, for the sake of time, I would like to stop here. And if you have questions, I'll be happy to answer.
So Sylvia's raised her hand. Sylvia, do you have a question?
Yes, Richard, great presentation. And I was so glad to hear you say about how Jupiter is actually changing, because when Mike Caracas started taking those amazing pictures of Jupiter for us, I said, Jupiter looks so weird. Like, what happened to it? It looks like an alien planet almost.
Yes.
So I thought, the first thing I did was go into Google and say, what's going on in Jupiter? And I couldn't actually find news about Jupiter. Where would I go to find something like that? Do you have a website, for example?
We've got a Jupiter group on the ALPO. It used to be a Yahoo group. Craig McDougall is our contact there. And his contact information can be found on the ALPO website. Okay. So that would probably be a good start. I'd also go to the British Astronomical Association website. John Rogers, usually he's pretty up to date on Jupiter. I mean, he's really focused on Jupiter, and he's probably, knowing him, he's probably already written a little report on Jupiter. It's already, well, most of the apparition is over. So I'm guessing he's already written a paper or two, and he's also done a good job with sort of coordinating the Juno images too.
Oh, cool. Okay, thank you.
You're welcome, Silva.
If anybody else has questions, you can either raise your hand or you can simply put it in the chat box and we'll ask Richard.
Okay.
Hi, Richard.
Yes.
I'll throw hey there. Thanks again for the presentation, Richard, and making it happen for us. One thing that regarding the impact flash that was detected just on the 13th, so recently ago, a few of us were postulating that perhaps there was no remnants seen a short time after because the impact occurred in the equatorial zone where the winds shears were a little bit stronger. Is that a logical thought?
That is a good thought. And the wind shear, it's tricky because I think it also depends on the altitude. I mean, if you go up in the mountains, just here in Canada or the US, it's a lot windier than, say, near sea level. I've noticed that just and so even here on the Earth, the wind seems to be a lot stronger, 3 kilometers up rather than right at sea level. And that probably is the same case with Jupiter. So I'm guessing this object broke up probably well above the cloud tops. That's my guess. Cloud tops on Jupiter are roughly at 1 atmosphere of pressure, which is about the pressure here on the Earth at sea level. And if you consider, for example, the Chelyabinsk impact, that happened several, probably 10 kilometers above sea level. And so again, that's a good suggestion. I think it's something to consider and ponder. But my guess is this probably broke up several kilometers above cloud tops, and I'm not sure what the winds are at that altitude, and they could be even stronger. So that's certainly a plausible hypothesis.
Thank you, Richard. Appreciate that.
You're welcome.
I just had a question, if that's okay.
Yes, Ed.
Hi. Yeah, so thank you very much for the presentation. It's been really enlightening for me. You said that methane is high up in the atmosphere. Why is that?
Okay. Well, here it is. Methane, I need to phrase this right. A methane band image what it does, methane absorbs that light. So if methane is in the atmosphere, the light will not penetrate it. It'll be absorbed. But if you have a methane cloud, let's say way up, the light hits it and then it's bounced back. But if there's no methane cloud, the light is not reflected back. So if you've got a bright area and a methane band image, that means you have a high altitude cloud or haze made up of methane.
Okay. All right. Thank you.
You're welcome.
So Richard, you mentioned the Giant Planet Jupiter book. Are there any other books you would recommend?
John McAnally came out with one about 14 years ago. I read it. It's very well referenced. I will say that's a very good reference book, and it's put out by Springer. I think it's Jupiter and How to Observe It. And again, that was put out about 14 years ago. I'm not aware of any more recent books. There's been a few that are sort of popular type. I have put out a very small book through the Astronomical League. I'm not sure you're familiar with them, but they're a huge confederation of astronomy organizations in the United States. They're pretty similar to the RASC. It's sort of a confederation of astronomy clubs or centers, if you want to think of it that way. And my book is I think it's $15, and Astronomical League gets all the profit there. But you might want to check that out. Just go to the Astronomical League website and go to their online store. Now, I will caution you, the Astronomical League is going through a software update. I think they're going to transfer their website over to WordPress. And so again, but yeah, go to the website. You might be able to call them up and just pay for it by check the old-fashioned way until they get the electronic transactions taken care of. But yeah, that might be a good start right there. And that was just put out 2 years ago, I think.
Okay, and the title of the book?
It's it is a believe. Let's see if I've got a copy here in my office. I may not. I think it's called Observing Jupiter in the 21st Century. I think that's the title, but I don't see a book here. I should have one. I think I've got mine at home. No. Yeah, I should have brought that with me tonight. But I believe it's Observing Jupiter in the 21st Century, I think. But it's on the Astronomical League website.
Okay. Sylvia, I see she has her hand up again.
Okay.
Actually, it's Gerry over here at Sylvia's, but I just wanted to get your opinion on the issue of, we always regard the Great Red Spot as being a storm, and yet isn't it a high pressure area? And how are we supposed to, like, we don't have high pressure storms so much on this planet. How are we to think about this situation?
Yeah, I think you're right. I believe the winds go in the wrong direction for the Great Red Spot, and we have had, yeah, there was a modeler who did a lot of modeling on this back probably 15 years ago. He was at California, Berkeley. I forget his name now, but you're right. You've got a high pressure area, and it extends up to very high altitude. That's the other thing.
Oh,
And oh yes, we see that's white in methane band images. It may be the highest altitude. Now that's not to say that it doesn't go down deep either. And anyway, but I'm not as up to date on the theory as I should be, but I do know that it sticks up way above too, and the winds are changing, at least what we can see. I hope that answers your question. That's about the best I can do.
well, yeah, I mean, it obviously still remains a bit of a mystery because we've got no way of seeing down in deep enough to know what's going on inside.
Yeah. Now, one thing that could help is getting or utilizing more wavelengths of light. Very recently, and I believe I'm speaking in the last 18 months, we had a couple of interesting papers in the Strolling Astronomer about an individual using thermal cameras to image the moon. And when I say thermal, I'm talking about wavelengths of about 8 to 10 microns. I mean, these are, our atmosphere transmits these wavelengths. The problem is resolution. You lose tremendously on resolution. I mean, a 1 meter telescope in that wavelength is like a 40 millimeter telescope in visible light.
The price we pay.
Yes.
Okay, thank you.
You're welcome.
Do we have any other questions for Dr. Richard Schmude? So I think we've got is there anything else you'd like to talk about now, Richard?
That's about it. I haven't been to Canada in 6 years. I'd like to go again. But at this point, we're just going to have to see how things settle down. We've obviously got a serious situation on our hands, and hopefully that will end soon. I pray for anyone who's got a loved one who is dealing with that right now. I know that we've got one individual at our college who's dealing with it. So anyway.
All right. Well, Richard, on behalf of the RASC Winnipeg, I'd like to thank you for tonight. It was very entertaining, very appropriate too, because planets are so well positioned for us to observe right now, and they're very easy for the beginner. You know, either by visual, just with your eyes, or opening up and tape on binoculars. It's something that's available to all of us, and it's really good that you were able here to talk to us and tell us some more about it.
Thank you.
Thank you.
Well, one other thing, you might want to start getting ready, because Jupiter's going to be very well placed in the next 3 years. And in October, it will be, it will be big, and its declination is getting further north, which is obviously good for both of us.
Absolutely. Well, again, thank you very much.
You're welcome.
And it looks like lots of people are saying great talk there, Richard, in the chat. So now for everybody else, we're going to take a 10-minute break, but we're going to stay live. So that for those that want to have a little bit of social time, we can do that. For those that need to get up and stretch their legs, and then we'll continue on with the regular business of the meeting. So about 10 minutes, and then we'll reconvene. And the mics are open, so everybody can either, if you've come up with another question, Richard's not still on, or we can just chat to say hi to everybody. And I'll say hi to everybody, and it's nice to see everybody. And now it goes quiet for a couple of minutes till everybody starts talking.
Oh, wow.
Richard, I was wondering if there's any other, about amateur contributions to your research. I know you've mentioned about getting images in even the UV light, and as well as the methane. But as far as what else would amateur astronomers do to contribute to the scientific knowledge of the planets, in your opinion?
Well, I think the way to go is to think about the technology we have today, 2021. And Christophe Pellier, he's a French amateur astronomer. Him and 7 others, or 6 others maybe, have teamed up, and they've written an excellent book. It just came out this year. I think it's from Axial Publishing Company. I think that's a French company. I tried to get it here in the United States, and I can't through Barnes & Noble, so I might have to just order it online. But that would be a good start. And Christophe is actually doing a lot of good stuff. And what you do is you've got imaging. You all already taken great images. What you need to do now is take that image. It's got brightness data all in it, hundreds of brightness measurements. And what Christophe has done is he will say, okay, let's look at the reflectivity of the North Equatorial Belt for July of 2021. And then we can look at the reflectivity in August of 2021. We can actually measure to see if that belt is getting brighter or dimmer. We can get quantitative measurements, not qualitative. We've been getting qualitative for decades, but we can get quantitative measurements. And Christophe is sort of leading the pack there. I've been doing J and H filter photometry. I'm not sure anyone else is doing that. That's in wavelengths that are beyond commercial CCD cameras. But the wave of the future I see is to take two techniques and join them. Like, for example, imaging and photometry. Photometry is just a measurement of brightness. Join them together, we can do a lot. And even, I'm not sure the spacecraft are doing this, but again, you have to calibrate. There's going to be a lot more math involved, a lot more probably computer programming, but it can be done. So amateurs, and that's one thing I want to stress to everyone. We can still make a contribution. I know there are probes orbiting Mars. There's still one orbiting Jupiter, but we can still make contributions, but we can't use techniques from the 1970s. We have to go beyond that. And of course, the constant imaging in and of itself is great, but we can even go further. And like I said, start getting quantitative brightness measurements of individual features, perhaps get quantitative polarization measurements. I don't even think the spacecraft are getting polarization measurements. So this is something we can do.
That's fascinating, because the book that you're referencing, I did manage to get my hands on a copy.
Yes.
It just popped up, and I think I'm on Christophe's mailing list.
Yes.
So he sent it out, and I thought, well, I really need to get this book. So I got it, and I started reading through it. Actually, the information is daunting. It's so condensed. I think I paid close to $100 on it, but it was a good $100 spent.
Yeah, I agree. It's
obviously I need to go to school on it more, because I didn't get to that chapter you're referring to yet, Richard.
It's well, he sent me some Uranus data just last November of 2020, and he actually got the reflectivity of the North Polar area that Silva talked about a little while ago. Mm-hmm. And it's not that much brighter than the other areas in green light. But you go out to the red or the near infrared, it's a big difference. And of course, that confirms the visual observations.
Can you put the name of the book in the chat, and if you have a link?
I wish I did.
I'll get the book for you, Susie. Hold on.
Another thing that changed on Jupiter is the red spot, right? Like I remember it was so salmony, it was barely visible.
Yeah.
And then it got really red, but it got smaller too, right?
Mm-hmm. I think you're right. I think you're right. I'm not sure why, but possibly there could be some kind of chemicals coming up. But again, these the measurements that I just talked about, getting absolute color measurements, brightness in different color filters, getting a number, not just, oh, it's redder. This can give us a lot of new insights, and even polarization measurements can give us some information. And wouldn't it even hurt to, even the methane band image, we can see if it's getting higher or not. Looks like the methane band images, the great red spot is overexposed, but you can cut down the exposure time and perhaps see, is the great red spot getting higher with time? That would be an interesting little project to do.
Sure. I love comparing those pictures that Mike makes with the color picture, and the other one is near infrared.
Yes.
And,
Yeah.
and just checking out the little differences, you know, you can spend so much time and it's like, okay, I wonder what's happening here that is different. So that's another layer of information that we are able to get from Earth.
Exactly. Yes. We just have to, like I said, keep up with the technology, and it's really good. We have got a lot of good instruments at our disposal.
Mhm.
So yeah, and maybe you can pick up where my generation is left off.
Yeah, it's amazing what we are able to do now.
Mm-hmm.
I know the first thing on my list of purchases I have to make is a methane filter, because I actually don't have one. And I know you mentioned before, Richard, about the advantage of going with the UV, ultraviolet spectrum. I found out in order to do that, I have to remove the glass filter, the glass cover, protective cover over top of the sensor, because it blocks that wavelength of light.
Yes.
Which is really unfortunate, because now you're going to have to clean that sensor a whole lot often. I've been a little bit hesitant about doing that yet.
And one other thing with the UV light and even the blue light, you got to make sure you don't have a near infrared leak.
Mm-hmm.
And unfortunately, some images, they've got that leak. You know, I think some of the 2U cam images of Mars back almost 20 years ago had that problem. And so you have to pay attention to the infrared leaks. And you know, you can utilize, unfortunately, I think there's a couple out in the United Kingdom, Ackerman, Mr. and Mrs. Ackerman. They've actually taken images like closer to 2 microns. And again, this is beyond the commercial CCD sensitivity. And if you look at Richard McKim's Mars report, I think from 2012 or 2010, he mentions them. Very little work is being done between 1 and 2 microns. And our atmosphere, actually, believe it or not, it transmits that wavelength better than visible light.
Which is awesome, considering how poor the seeing is up at North 50 here where we are. It takes, we have to use other techniques to get some decent images.
Yes, yeah. You all might want to think about, you know, going a little further out. I'm like I said, I've got the SSP4 photometer. Fortunately, I got a little grant from the college, and it's about $4,000 US. And but it's really been, I don't know if anyone is doing J&H filter photometry of the planets right now besides myself. Now they are using these filters for variable stars, AAVSO, but I don't know of anyone using them for planets, and particularly Mercury. Of all planets, I was shocked. I've been able to get good Mercury measurements.
Wow.
Because the atmosphere is so transparent at that wavelength. Of course, that's something, yeah.
Well, Rich, it sounds like you have a lot of data that you can be using for lots of papers that you can write.
I've been trying to keep up with them right now. The Mars book has kind of slowed me down, but you're right. Yeah.
And can everybody see my screen?
Yep, looks good.
There we go. Okay, so obviously we thank Gerry there for his session. As you see, everything was mixed up a little bit tonight, so I'll be doing our welcome and so announcements. I'm going to talk for a few minutes about the bylaws. Then Jay Anderson will do what's up, and then Dr. Danielle Pahud will do what's new. So just on the announcements, This is the first notice that the final copy is on the website, and I'll be showing everybody that, and it will be voted on at the December meeting. Mission, vision, and values are on the website as well, and I'll show you where those are. St. Malo's spring event last week in April. We are recruiting for volunteers. This is similar to Spruce Woods, but we're looking to do an event out in St. Malo, and we're looking for volunteers. If you're interested, please contact the council, and we will gladly let you know where we can use you to volunteer. Telescopes for Kids, our holiday giveaway was announced, has been sent out and letting everybody know about it. So if you're interested in participating or perhaps have a slightly used or a new, or even want to donate a new scope for that, please let us know. Breakout rooms, we're not doing that tonight. Public events, we've had a couple of public events. The TP one that happened last night, and then we had the one with the Scouts Canada 2 weeks ago. So again, it's nice to see we're starting to do public events again. The one thing I do want to remind everybody is that if you're planning an event, you need to notify council so that we know that the event's happening. It's a notification. It's not necessarily looking for permission. And it's mostly to make sure that if you're representing the RASC, that we, the council, are actually informed of it. So all it is drop us a quick email, let us know what you're doing and how many people you expect to be there. Our last speaker last month talked about his research in Mars geology and the places they go around Manitoba to do geology research for Mars, has agreed to put together a field trip next summer. So we're just giving you a heads up on that, and that we're expecting sometime in the spring, sometime probably after May, we're putting together a field trip. We're not sure whether it'll be a 1-day trip or possibly a 3-day trip. And that'll be open to all the RASC members of Winnipeg Centre. So we're kind of looking forward to it. We got a taste of what we could be seeing and how it relates to the research on Mars. We're actively recruiting a meeting coordinator, and the meeting coordinator is a person who will simply just help line up all our speakers, make sure everything's set up for the meeting, and also make sure our speakers get a thank you gift when the meeting's over. We're also looking for a volunteer coordinator, and that's a person that would probably be working if you had an event that you want to do for public events, and they would just work with you on that. We're also looking for volunteers for meeting presenters. So what's up, what's new, any other of the sessions or a different session that you'd like to do. We just ask that you let us know on the council, and we'll certainly set you up so that you'll be able to do some presentations at the meetings. Lunar Scope Coordinator, there'll be a new person announced shortly that's coordinating our Lunar Scope. And we just also want to let people know we now have, thanks to a kind donation, a very nice set of binoculars on a tripod available for the Lunar Scope. So if you're interested, for the time being until the new coordinator is announced, please contact the council and we'll let you know. We're giving a heads up. The AGM is in January, and we'll be looking for nominations. If you want to nominate somebody or to be nominated to be on the council, please notify Brian. Brian is the coordinator for the nominations. Interest groups. We've had some people contact us about setting up some interest groups. One interest group that may be starting up is binoculars, and then there's some others in specific scientific research areas that may be interested. So again, pay attention to the website as these groups start becoming developed, or our social media. They will be announced, and then you'll be able to get in contact with the person coordinating that group. Award nominations. If you have somebody you'd like to nominate for either one of the national RASC awards or one of the two center awards, please submit the name to the executive, or not the executive, to the council, and we'll be gladly review it and hopefully see where that goes. The bylaw information session is going to happen right after this meeting, and the next meeting will be November 12th, and we're just mentioning that mostly because we want people to, last year we had to change it to the week after because of Remembrance Day, but Remembrance Day does not fall on the Friday this year, so it will be November 12th. And stop share. I'm just moving over to a different screen, I hope. Okay. So in order to find the bylaws, you go to our website. Once you're logged in, you have to be logged in to get there. There's this tab here, internal. There's all sorts of things in here. So council appointed minutes, bylaws, regulations, and then image galleries where you can send your images in and they'll be posted on the website. Membership programs, archives of all the different things from the past. What I want to focus on tonight is talk briefly about bylaws and regulations. So if you click on that, it brings you to this page. And in here, you'll see the strategic plan is in there. Eventually, our corporation papers will be there. Policies and procedures manuals being developed. But tonight, I want to focus on the bylaws. So we click on bylaws. As you can see, they say they're draft, and these are the ones that will be voted on in December. So to save time, I'm going to click over to this one. So there's a small preamble on the bylaws just to try and put some context before you actually get into reading them. So the main purpose that the bylaws are providing for us is that we will be incorporating as a nonprofit corporation in the province of Manitoba. And that will allow us to be able to do better fundraising as well as apply for grants for whatever we should choose to do, whether it's upgrades at Glenlee, our observatory, or anything else. It is not a charity that we're planning to become, and any charity work would be done and coordinated through the National Council or the national organization. The intent of the council is to have 8 directors consisting of president, vice president, secretary, treasurer, and 4 at-large directors. All 8 have voting privileges, and this 8 directors must meet criteria of the Corporations Act. Also, in the case of a tie, the president can opt to have a second vote or let the motion die. And that privilege of a second vote is only used by the elected president, is not passed along to people presiding over a meeting in their place. President, vice president, secretary, and treasurer are officers and make up the executive of the council. And those positions will be submitted with the annual report for the incorporation. In addition, up to 4 more councillors can be elected and have voting privileges. And this allows for youth under 18 members to participate on the council, although the councillor positions would not be included in the annual report. So we have councillors and directors. All of them have the same voting privileges. The only difference is that for the legal aspect of the incorporation, only the directors will be reported. There are 2 standing committees, finance and nominating, and it also has built in so that other committees can be brought on an ad hoc basis as required by the council. And this gives the council the flexibility to respond as we need to whatever the needs of the association is. And the policy and procedures manual will have the duties, contain the duties for council members and all the other job descriptions for the committees that will be active as and organizations that are going on under the umbrella of the council. The 4 executive positions will comprise the minimum number of council positions that must be filled by election in order to meet the requirements of the Corporations Act. So what all that means is that a minimum of 4 people will be elected, and they will be, at the very least, the president, vice president, treasurer, and secretary. So I'm only going to talk for a few more minutes. So this is the draft bylaw. Act, Centers, Winnipeg Center, Council is the body that made up of the 8 directors and 4 councillors. Members meetings include the center meetings and the annual general meeting and any special meetings of members. The national bylaw are those from the national RASC. National Council is the advisory board of the RASC nationally of the society. We've already mentioned who the officers are. Definitions talk about ordinary resolution, which is just normal things brought before for resolution. Meeting of the center. Special resolutions are passed by not less than 2/3 of such members present or by proxy at a general meeting or special meeting of the organization. I'll just move into the next one here. So the official name of the center will be the Royal Astronomical Society of Canada, Winnipeg Center Incorporated. We have in writing from National the permission to use the title, the Royal Astronomical Society of Canada. So that has already happened. The objectives of the center are to stimulate interest in the study, knowledge, and enjoyment of astronomy and related sciences by members in the public, to work in conjunction with the Society and other centers in the Society to further the progress of astronomy and observing in Canada, to acquire and maintain equipment, libraries, astronomical observatories, and other property necessary for the pursuit of its objectives, publish newsletters, books, and other material containing information on the progress of astronomy and the work of the Society and the Center, to receive and administer gifts, donations, and bequests from members of the Center and others, and to make contributions and render assistance to individuals and institutions engaged in the study and advancement of astronomy. Our mission and values all align with this. We can have a corporate seal should we choose to. The center is a constituent part and associated with the Society, and the Society is the Royal Astronomical Society of Canada. For the Constitution, the operation of the center is governed by the center's bylaws and the bylaws of the Society. So again, we're tied to National. The bylaws of the center shall not conflict with the bylaws of the Society, and any center bylaw that does so in conflict is inoperative to the extent of the conflict. So it means that the bylaws of the Society override ours should there be a conflict. And this 523 says the same thing. Center debts just simply states that the center is responsible for all our own debts, obligations, and claims. And we cannot, we're not liable for any debt, obligation, or claim incurred by the Society. Membership. Membership in the Society shall be open to those who are interested in astronomy as provided by the Society's bylaw. So we are open to everyone with the only condition you have an interest in astronomy. Membership shall consist of those who support the objectives of the Society and Center and who pay the annual fee to the Society treasurer in an amount under the terms and conditions determined by the Council and Society. Proof of payment may be required to access center services. So if your fees aren't paid up, you could be denied access to center services. So this is important. This has always been there, but it's just re-emphasizing that. We allow for transfers of membership between centers. However, you cannot transfer your membership to another person. And we'll just quickly go through termination, and that's probably all I will do tonight. So members at all time are expected to conduct themselves appropriately and with due regard to the best interests of the center, the Society, and their fellow members. Failure to comply with any of the bylaws or policies of the center or Society may result in disciplinary action or expulsion in accordance with the disciplinary action and expulsion policy. Any member whose actions cause disruption or prevent other members from participating may be subject to disciplinary action in the form of written reprimand or all the way up to removal from the center. If a person is removed from the center, then they are still considered an unattached member of the Society. So should you be removed from the center, that does not remove you from the Society. There is a clock on how quickly National needs to be notified and the individual. A member may terminate their membership in the Society by sending in written notice to that effect and to the center secretary of the center. The notice takes effect immediate. Now, also membership in the center may also be terminated when the member dies, member fails to maintain any qualifications for their membership in accordance with the bylaws or those of the Society. If by a vote of the majority of members of the center, a majority vote of directors of the center at a meeting duly called and for which notice of the proposed action has been given, the member's membership in the center has been terminated, or the center has been liquidated, dissolved under the Act, membership is in default of payment for 60 days past due. So really what this one means is that this is currently being used. You have 60 days to pay your membership once from the due date at the latest. At that time, you officially are removed from the role. And upon any termination of membership, the rights of the member, including any rights in the property of the center, automatically cease to exist. So just before I'm going to stop sharing, that's as far as I'm going to talk about tonight. Now, again, this is available. I showed you where you can find it so you can review it all. Did anybody have any questions over that brief section that I've just reviewed? Wasn't expecting any. Okay, so I'll just move on to the next slide then. So members observing night is tomorrow night, starts at 6:30. If the weather is not going to be conducive to it, then you will see an announcement sent out on the email. I'd like to now introduce our very own Jay Anderson, who will now do What's Up. Please welcome Jay Anderson. Danielle, I see your hand up. Did you have a question?
No, I was clapping.
Oh, sorry.
Sorry, it goes away.
Sorry, I'm icon illiterate.
Sorry about that.
No worries.
Well, that was a little bit of you managed to switch over to me just at the moment I was clicking to open up my presentation, and I ended up starting Google Earth. Anyway, here we are. What's up? October, November, beginning of the cold season. The picture of the Perseid meteor shower that I put together with Judy and Sheila protecting themselves from bombardment in the foreground here. Unfortunately, I had to paste them in. I didn't make them stand there for an hour and a half. So we have some interesting events coming up. Nothing too exciting, but something to keep us going now that the nights are getting dark very early. And we'll start with the sun. This is from a couple of days ago, but sunspot 2882 is actually closer to the center of the disk now and is actually becoming a little bit more active. We've been talking about the sunspot cycle over the last couple of months and how it has been proving to be more active than originally thought. You can see in the top graph on the right here that we were looking initially at having a fairly smooth and fairly low amplitude cycle 25, and we seem to be running with the September data that's in here now quite a bit stronger than that. But it turns out that they're not the only ones who made this that are making predictions of the solar cycle, and there's a separate technique which is being done which shows the cycle, a second kind of prediction coming up. I don't know which one of these has got my mouse on it.
The left.
Anyway, it's coming up at a much stronger, and so we have sort of seen some of the results of that with the level of intensity of the aurora, and we can only hope that we'll continue to see that along with it, with the sunspot activity. And it's fairly common nowadays to see multiple sunspots on the sun, which means that our presentations in the daytime to whatever groups happen to be hitting on us for doing a presentation, we'll have a little bit to look at. Well, we like some nice big groups. Planets in October, well, Mars and Mercury are more or less behind the sun. You can see the diagram of them here off on the right, with Mars it's a little bit above the sun and Mercury below it. Both of them too close in to observe in at any time of the day. Jupiter and Saturn are more or less dominant in the south during the night for most of the night. and they're pretty easy to spot in any kind of a decent dark sky. The interesting things about that is that the view that you get of them, because Jupiter is so bright, and because the two of them are relatively close together, they as a pair attract your eye quite a bit, whereas ordinarily on a dark sky you might have to look a little bit to identify Saturn. And Venus is up in the southeast, but as Gerry pointed out, the ecliptic is very low at this time of year, comes up at a very shallow angle from the horizon, so Venus remains low. It's visible because it's such a bright object, and it'll get a little better visibility toward the end of the month and into next month. But it's not going to be anywhere near as popular as it was in alternative parts of its orbit when it can get 45 degrees high in the sky. In November, Mars and Mercury are actually going to be in conjunction in the daylight. Here's a diagram where I've turned off the daylight glow, so the sun is down here, and Mars and Mercury are passing each other pretty close together. And again, because this is in the daytime morning side, the ecliptic's at a steep angle, so that these guys come up well before the sun, because everything is rising up in this direction. So they'll be ahead of the sun. Nevertheless, they're still going to be pretty low down. You might be able to catch them early in the morning, but more than likely, if you give them a shot during the daytime, then it may turn out to be the best view that you get of them. It's about a 15-degree angle between the sun and the two planets, so it shouldn't be too hard to see them. Saturn and Jupiter next month are sinking down into the southwest, not the southeast. Still easily visible because they're bright, and Venus is more or less hanging in the same place, low in the southwest during the evening. Uranus is in the south and southwest. It's all visible through the night, as is Neptune. Both of them you'll have to search for. When you look at the night sky, here we are on the 10th, that's Sunday night at 10 p.m. with a somewhat brightened Milky Way in this view. And you can see, looking to the south, the center of the Milky Way is starting to be a little bit on the low side now. It'll be the moon in the way at the time, although it's still coming up and increasing in size. But the Milky Way, especially the part of it that we're most familiar with at this latitude, with the 3 stars that mark the summer triangle, still lots of goodies up in there to be looking at. You can see Saturn and Jupiter in this view here, Saturn in front of Jupiter by 15 degrees or thereabouts. And if we go into the next morning, you can see that I'll just alternate back and forth. It's like the hands on a clock. The Milky Way is rotating around the sky. Now, Deneb here, which is one of our stars of the summer triangle in here, has now rotated so that it's getting down toward the horizon. Deneb is circumpolar at our latitude, so it never sets, but that and Canopus are probably the 2 bright stars. Anyway, what you're starting to see is now our winter constellations, and we have this cluster of very bright stars that mark the winter constellation. Here they are up on the side, and they're stars that we should all know the names of because they do stand out so much. And of course, Orion constellation, being the brightest constellation, has got 2 of the very bright stars in it. And with Sirius stands out, really marks the whole of the winter. We get up into November, the 9 o'clock or 8 p.m. view in November, Milky Way is rotated partway around, not as far as it would on an overnight, but again, by 8 o'clock in November at this time, we'll be seeing mostly the square of Pegasus in here as a prominent evening asterism or constellation. And we're sort of watching the end of the summertime and the arrival of some of the wintertime parts of the Milky Way. Ecliptic is now higher. Jupiter and Saturn are still prominent, but now they're a little bit closer to the southwest horizon. Just to sort of spread it all out and show it a little better, Celestia, which I'm using to make these charts, is not particularly good at handling the planets, but you can see that when tonight you've got, this is 8 p.m., we've got Venus low in the southwest, we have the moon, Jupiter and Saturn, Neptune and Uranus spread out across the whole of the sky in the evening. When we get up into November, again, we say at the same time, we have the moon a little bit earlier in its phases. Saturn and Jupiter now in here. Neptune and Uranus are now higher in the sky in the evening. And of course, these will go through their nightly cycle. Pretty pictures. Well, Sunday night, Venus and the moon are together with each other in the nighttime sky, in the evening sky. Here's a picture of them. Pretty close now. This is at 7:15, but again, the moon might be a little bit tough to see, but Venus won't be and should lead you to them without too much trouble. In October 14 and November 10, those are the two nights when the moon, one lunation apart, where they pass under Jupiter and you get this sort of broad triangle. Here it is in October with the moon, Jupiter, and Saturn. And similarly in November, almost the same type of appearance. And if it were clear on those two nights, it might make for an interesting picture to compare the two of them. We have a meteor shower peaking tonight or last night, so I mentioned it. We do have the Orionid meteor shower peaking on the 21st. I'll say a little bit more about that later. Mercury on later in the month is at its greatest western elongation in the morning sky. That'll be our best view of the year for this hemisphere. November 4, I've encountered another stupidity, which we now have the super new moon. So the challenge is for you to photograph, be the first person to photograph the super new moon. So if we get that, if you manage to get that picture, guaranteed for Sky and Telescope. And then on November 7, we get the very thin crescent moon occulting Mercury in the daytime sky at 4:54 in the southwest. And that presents more interesting than the Mars conjunction that I talked about, Mars-Mercury. Here we are with a little look at the Orionids. You can see the radiant of the Orionid shower is a little bit off and above Betelgeuse, a pretty easy spot. If you're going to see this, you'd want to probably observe in this part of the sky around Orion. It's debris from Halley's Comet, and it's not a particularly active shower, especially as there'll be a bright full moon on that night. So if you're anxious to see a meteor shower, it's one to go and try out, but it's not going to overwhelm you the way the outburst in the Perseids did this year. Here I have a picture of the occultation of Mercury by the moon, and this one is in daylight. You have to be looking at it. This one's in the evening. Again, it was Mercury. This is 15 degrees from the sun. The other one was a little farther than that. Mercury will appear to be at about minus 0.4 magnitude. And in fact, actually, the moon is so small or so thin that it would be a real challenge to see because they're not very high up in the sky. It's something to wait for, maybe mark it down on your calendar when this thing comes along later in the month. And then just a heads up here, a heads up a little bit beyond my normal time period, but on November 19th, we have a almost total lunar eclipse. You can see there's just a tiny little piece of the moon that sticks out from below, underneath the umbral shadow. The whole eclipse is visible here at Winnipeg. So no excuse not to see it. November 19th, you just have to be up at 1 a.m. in the morning and stay up until 4:45 in the morning. And November 19 is guaranteed to be cold, even if it isn't as cold as we're used to. So keep an eye on that one because we haven't had a good lunar eclipse for a year or two. And finally, here's the cat. Thank you very much.
Thank you, Jay. And next up, we have Dr. Danielle Pahud with What's New?
Hi, everyone. Do I have the ability to share my screen? Guess I can just try.
Yes, you should. I granted co-host
Yes.
you. Okay.
Perfect. Thank you. All right. So let's try this. Can everybody see?
We can see your screen.
Yeah, I'm trying to make it to go into presentation mode. Can everybody see that? It's thinking about it. There we go. Okay, can everybody see?
Yeah,
Yes,
I
we
see
can.
it.
Are you seeing the two panels or just the one?
It's in movie mode, so it looks good.
Yeah, just the one.
Perfect. Okay. All right. So I'm going to present two pieces of astronomy news today. So one of them will be in the solar system and one of them is going to be outside. So the first one is that Pluto's atmosphere is becoming less dense, which is the opposite trend than what's been observed for the past 25, 30 years. And then finally, a supernova blast makes way for a star factory. And this is some astronomy theory that is a little bit of astronomy canon, but there's some new observations that really support it in a way that hasn't been done before. So I am basing my first piece of news off of a space.com article by Chelsea Good. And I went to go read the science article, but it was presented, it hasn't been published yet. It was presented this week at the 53rd American Astronomical Society Division for Planetary Sciences at the annual meeting. And this is based on results from Elliott Young et al. And so it involves Pluto. So Pluto, just to make sure everybody's on the same page, is a small, cold, and distant dwarf planet with an atmosphere. It has an orbital period of 248 years, an orbital distance that ranges from 30 to 50 astronomical units from the sun in a fairly elliptical and tilted orbit. And the surface temperatures range from minus 228 degrees Celsius to minus 238 degrees Celsius. So as cold as it gets in Winnipeg, Pluto is colder. So this is a beautiful image from the New Horizons spacecraft of Pluto and kind of this famous heart-shaped whale tail. And I'll come back to that in a little bit. This is where Pluto is today relative to the sun and the other planets. So we have Jupiter and Saturn relatively lined up. And we can see that Pluto's orbit is crossing Neptune's. And it was closest to the sun about 25 years ago. And it is slowly moving away. Also New Horizons is here, which I thought was fun. All right, so a little bit about Pluto's atmosphere. So Pluto's atmosphere is tenuous, meaning that it's not very dense. It's made up, like Earth's, of mostly nitrogen, but it also has traces of methane and carbon monoxide. The atmosphere is supported by the vapor pressure of its surface ices. And so the presence of the ice really helps determine the density of the atmosphere. Okay, sorry, there we go. Just getting the chat so that I can see it in case anybody has questions. And so this is an image from NASA and Johns Hopkins from the New Horizons spacecraft of Pluto's atmosphere. So this is kind of looking back towards the sun with Pluto backlit. We have this blue haze from nitrogen reacting with some of the methane to make kind of this soot that's bluish in color. And so we can see Pluto's atmosphere here. And so past observations of stellar occultations of Pluto have shown that Pluto's atmosphere is getting denser and denser despite moving further and further away from the sun over the past 25 years. And so Jay did a great mentioned occultation several times within our planet, or between planets in our solar system and the moon. We can use occultations of planets in our solar system and distant background stars to get a measurement of the atmosphere of the planets. And so if a star has a certain background brightness, so if we focus on this white panel here, if a star has a relatively constant brightness, so here and here, then as a planet moves in front of it, if the planet had no atmosphere, we would just have a sharp drop as the planet blocks the star, and then it would be dark for the duration of the planet's transit or occultation of the star, and then come back. And so we can use the shape of this transition from brightest to lowest to determine the properties of the atmosphere, specifically the density of the atmosphere. And so these types of observations have been made for Pluto since 1988. And so the rate at which the star's brightness decreases and then increases as the occultation ends determines the density profile of, in this case, Pluto's atmosphere. And so these occultation measurements have been done regularly since 1988. And then in 2015, when New Horizons flew past, it obtained an excellent density profile of Pluto's atmosphere, which largely supported the occultation observations. And these observations showed that despite moving further away from the sun, Pluto's atmosphere was getting denser and denser, and it would double about every decade. However, in August 15th, 2018, there was an occultation, and it was observed by Elliott Young and colleagues. And the entire occultation lasted about 2 minutes, but it showed a reversal of the increasing density trend. So here, the larger panel in red is the center line for the occultation, and the blue are the southern and northern limits. And then each of these little telescope icons are observations. And so this observation in particular is taken by Elliott et al. Here, kind of at this location. And something that's particular about this observation is this bright central spike, which is an observation of the light being blocked, starting by being blocked by Pluto's atmosphere. And then once Pluto is centered in front of the star, the star's light gets refracted and kind of beamed towards the observers on Earth. And so you expect to see this flash if you're right on the center line. So this gives you a really strong constraint for where the observers are relative to Pluto's shadow on Earth. Okay, so I already talked about this a little bit, but the 2018 observations showed a decrease in brightness with a bright central flash, which is the refraction around Pluto's atmosphere. And so this light curve, instead of having a typical U shape, has a double U shape. And I've already talked about the refraction. So why is it that Pluto's atmosphere was increasing while it was moving further away from the sun, and why has it now stopped? And so the theory currently that the data support has to do with thermal inertia, and this is that the peak temperature lags behind the heating rate. And so the authors use an analogy where even though the sun heats the sand on a beach most effectively at noon, because the heating is happening faster than the sand is losing temperature, the temperature of the sand actually keeps increasing over the course of the afternoon. So the sand is really hottest towards the end of the afternoon. And so there's kind of this delay in peak temperature in sand behind the peak heating rate, which would be at high noon. And so this is what the scientists think is also happening on Pluto, in that it receives its highest heating rate from the sun when it is closest to it, but then it keeps getting heated, and it has stored some of the heat and melted some of the methane ice and creating a denser and denser atmosphere. And now it's far enough away that the sun's heating is not effective enough, and the surface temperature of Pluto is cooling, which means that the ices are refreezing on the surface, and the ice vapors are decreasing, so that the pressure is not enough and the atmosphere is essentially refreezing onto the planet. And so they think that there are some large nitrogen reservoirs, and they're kept warm by the rocks of the surface, under the surface. And so the largest nitrogen reservoir is Sputnik Planitia, which is the western lobe of the heart-shaped Tombau Regio. And so the decrease in atmospheric density means that the stored heat is starting to dissipate, and the atmosphere will refreeze onto the planet eventually and disappear until Pluto comes around again. Okay, so the next piece of news is a supernova blast makes way for star factories, and this is by Monica Young in the Sky and Telescope magazine. This was published September 23rd. And so astronomers here have used observations of dust to create a 3D map of dust clouds in the Perseus and Taurus constellations. And then they've used modeling to show that it's actually dust clouds that are draped over a spherical cavity, and we're just looking at the cavity from the outside. And so the clouds are on different sides of an evacuated bubble, and they posit that this bubble is actually a supernova remnant, or a cluster of supernova remnants, and that this has pushed the gas in these molecular clouds together and is kickstarting star formation. Excuse me. So molecular clouds are large, dense, and inhomogeneous regions of gas and dust. So they're really clumpy. So this is a beautiful Spitzer image of a large molecular cloud. And you can see that there are certain regions that are much more dense than others. And so there are clusters, and there are clumps, and then there are cores, these little dots. And we think stars come from cores that are the densest parts. But typically molecular clouds are the location of star formation rates, of high star formation rates. All right, so locating these particular molecular clouds. So the Perseus molecular cloud is kind of up in Perseus by his foot near the Pleiades, and the Taurus molecular cloud is kind of makes a triangle with Aldebaran and the Pleiades here. I'm sorry, the contrast on this isn't so good. But this gives you a sense of scale for these clouds in the sky. And so the way that this study was done is astronomers used measurements of the European Space Agency's Gaia spacecraft to measure the ultra-precise position and distances to millions of stars and mapping their distribution in the galaxy. And then using the spectra, because we know how bright a star should be from its spectrum, we can contrast that to how bright it actually looks at all wavelengths. And from there, infer the column density, or how much dust exists between you and that star. And so then if you do that for multiple stars in generally the same direction, but at different distances, you can get a distribution of dust at different distances away from you. And so what this allows us to do is, in addition to having the best 3D map of star distribution around us in space, it also allows us to create the best 3D dust distribution in space that we've ever had. And so this was created here, a 3D map of distribution of dust around the solar neighborhood. And so this was constructed by Lyons et al. And so with the sun at the center, the Perseus and Taurus dust clouds are shown in blue and red, and so they look kind of spread out. But if we put the center of the space we're considering between the dust clouds, then the sun kind of gets moved over here, so we're looking at it from this side. And so from this perspective, it's a lot more apparent that these could be dust clouds that sit on either side of an evacuated cavity, so this big bubble. And so these astronomers posit that the cavity is consistent with kind of a space that would have been a supernova that's been evacuated by a supernova. So the cavity itself is 700 light years away and has a radius of 250 light years. The interior gas and dust are consistent with having been swept up in the wind of a supernova. There have also been X-ray measurements that show that there are some high energy sources in that area. And there's also a high fraction of iron-26 isotopes, which is a common supernova product. Aluminum-26. So the size of the bubble implies that the supernova must have gone off at least 6 million years ago. But the bubble isn't expanding anymore, so it could be older. However, the bubble hasn't yet dissipated, and so that gives it kind of an upper age limit of 22 million years. And so all of this is the best 3D evidence that astronomers have so far of kind of a common sequence of events that we thought happened, and this is the best evidence that we have for it happening in 3D. So we typically think that there's cold dust and clouds kind of strewn across space. A supernova or a series of supernova go off. The shock wave from the supernova will compress molecular clouds and these clouds and dust. And the extra compression will kind of give gravity a hand. The clumps and cores will compress down to have pressures and temperatures that are high enough to start fusing hydrogen at the center of these cores, and then stars will be formed. And then we'll have kind of this wave of star formation in the wake of the supernova shock wave. And so this is an image of it happening. And so this Perseus Taurus cluster bubbles, some of the best evidence that we have of it happening in 3D and at this particular stage. Okay, these are my references. Thanks, everyone.
Thank you, Danielle. Does anybody have any questions for Danielle? Great. Well, thank you very much, Dr. Danielle Pahud. And with that, everyone, that brings us to the end of our meeting tonight. I'd like to thank everybody for coming and listening in, and thank you again to all our presenters. And we'll now move into our online friendly get together and have a drink or a chat and say hello to everyone. I've got to step away, but have a wonderful evening, everyone. Good night.